Now we're going to describe collisions in terms of momentum instead of just separately mass and velocity. So this is gonna be, let's call this ball 1 here. It has a mass, and we're gonna let it move, so it's gonna have a velocity, and so it's gonna have a momentum before the collision. And let's just say that the ball represents that unit of momentum before the collision. And let's see what happens after the collision. So after the collision, you notice that, if one ball enters and one ball, so the red ball enters, one red ball enters and one purple ball leaves. But in terms of units, one ball enters and one leaves. Essentially what that means is that if there is no external force acting, then the total momentum before the collision is going to equal the total momentum after the collision. So let's look at it in this case. So let's say that you have two balls. So 2 units of momentum enter, and notice that 2 units of momentum leave. And let's try 3. So you can have 3 units of momentum before the collision, and after the collision, 3 units of momentum leave. So always, the total momentum before the collision is always going to equal the total momentum after the collision. So you can go to 4. So 4 units of momentum before the collision, and 4 units of momentum after the collision. So this is called the conservation of energy. And what it says is that before and after the collision, if there is no external force acting on an object, the total momentum before the collision is going to equal, well, in this case 3 here, is going to equal the total momentum after the collision, which is also going to be 3. Here then we're going to describe the idea of conservation of momentum. And what it says is that if this is before the collision, and this is after the collision, and let's say that you have 2 objects, so you have an object with a mass, object 1 and object 2. So object 1 is going to have a momentum P1, and object 2 is going to have a momentum P2. Let me just say that this is going to be P1 initial and P2 initial. So this is before the collision. And let's say if they're moving at some random velocity, but the combination of their mass and velocity, we're going to call that momentum. So before the collision, each object has a momentum P1 and P2. So let's just say that before the collision, the total momentum, P total initial, is going to be momentum 1. So just P1 initial plus P2 initial. And now, after the collision, they collide, and now they're flying off at some other random velocity. So this is mass 1, this is mass 2, and now because the velocities changed, or the speeds changed, that means that the momentum changed. So that mass 1 is going to be moving with the momentum after the collision. I'll call it P1 final. And mass 2 is going to be moving with the momentum after the collision. I'll call P2 final. And so after the collision, the total momentum is going to be P total final, which is going to be P1 final plus P2 final. So the basic idea is that you always find the total initial momentum and the total final momentum. And the conservation of momentum says is that whatever these objects are doing, whatever their mass and whatever their velocity, all those things can change, but something is going to always remain the same if there is no external force acting on the object. And what is always going to be the same is that the total momentum before the collision is always going to equal the total momentum after the collision. So this is called a conservation of momentum.